Hi, in this video I want to show you what are the forces that are exerted on a 1¼ inch pipe in a 24-inch pipe wrench when we apply 125 pounds of force into the handle of that pipe wrench. So after I placed the pipe on a pipe wrench, I realized that this point is the common force point between these two members, that member and that member. So this is the picture I got, and the dimensions are exact. So let me go ahead and sketch both this portion. That portion will be so at this point, point A, we are going to have force in a y direction. So let's again, we are going to be using the xy axis. And we also have a force at that point, force A in x direction. And at this point, we are going to have force C in y direction and force C in x direction. Now for this portion, we are going there again. At this point is our point C. We are going to have force at point C in x direction and force at point C in y direction, and in here at point B, we are going to have force at point B in y direction and force at point B in x direction, and also we are pulling that handle 125 pounds. So again, using statics, engineering static, we can find all the forces that is applied in that pipe wrench. So for static equilibrium, again, the summation of all the forces in x direction must be equal to 0. The summation of all the forces in y direction must be equal to 0. And the summation of moment with respect to any point in our system must be equal to 0. So let's go ahead on this portion. If we get summation of all forces on x direction equal to 0, so the forces that we have on x direction is, let's assume that this direction is positive, so we have force at point A in x direction minus force at point C in x direction equal to 0. So from here we can see that force at point A in x direction must be equal to the force at point C in x direction. So force at point C at point A in x direction is equal to force at point C is x direction, and the same this is this is equal to force at point A in x direction. Now, if in the same picture, we get the summation of forces in y direction equal to 0, and let's assume that upward is positive, so we have F force at point A in y direction minus force at point C in y direction must be equal to 0. So the force at point A in y direction must be equal to the force at point C in y direction. Force at point A in y direction. So that means that in our pipe wrench, the forces at this point, this common point, are the same forces that are on top of our 1/4 inch, 1 1/4 inch pipe. At that point A, are the same forces. Now, again on this picture, let's take the summation of the moment with respect to point C. So this is our point A, this is our point C. So we know that the summation of moment with respect to any point must be equal to 0. So we have force, let's assume that this is the positive direction. So we are going to have force AY, force at point A in Y direction, going the positive direction toward point C. So we are going to have force at point A in Y direction multiplied by the distance between point A and point C, multiplied by that distance, which is 1 inch, multiplied by 1 inch, then we have this force, which is in negative direction, minus force at point A in x direction multiplied by the distance between point A and C. The force is going this direction, so the distance between that force and C is 2.75 is 1.25 plus 2.75 multiplied by 4 inch equal to 0. So that means that if we solve this, the force at point A in y direction is equal to 4 times of the force at point A in x direction. So the force at point A in y direction, which is equal to the force at point C in y direction, is equal to 4 times the force at point A in x direction. Now let's go to this picture. In this picture, let's go ahead and take a summation of moment with respect to the point B. So we know that the summation of moment with respect to point B must be equal to 0. So again, let's assume that this is the positive direction. So we have this force that is going to point B in a positive direction, 125 pounds, multiplied by the distance between this force and point B, which is 14.5 plus 2.75. So will be 16, will be 17.25. So 125 pounds multiplied by the distance between this point and point B. We are taking the moment on point B, will be 14.5 inches plus 2.75, so will be 17.25 inches. Then we have this force FCX, which is going again on a positive direction to point B, so that would be plus force at point C in x direction multiplied by the distance between point C and point B, multiplied by this distance, which is from point C to point B, which is 2.75 inches, multiplied by 2.75 inches. Then we have this point, force at point C in y direction, which is going the negative direction, minus force at point C in y direction multiplied by the distance between the point C and point B, which is this distance, 1 inch, multiplied by 1 inch equal to 0. So if we simplify this, we are going to have 2.75 FCX minus FCY plus 125 multiplied by 17.25 plus 21 56.25 equal to 0. Now, we know that the force at point C in x direction is the same as the force at point A in x direction. So we can write this, we can substitute, we can write this at 2.75 multiplied by the force at point A in x direction, because these two forces are equal, minus FCY. Minus FCY. Instead of FCY, we saw that the force at point A in y direction equal to the force at point C in y direction equal to 4 times the force at point A in x direction. So minus, instead of FCY, we can put 4 times force at point A in x direction plus 2156.25 equal to 0. So now here we are going to have minus 4 FA. We can solve this equation for FAX. So minus 4 FAX plus 2.75 FAX is equal to minus 1.25 force at point A in x direction. All we are doing, adding minus 4 and 2.75 will be minus 1.25 FAX equal to, we subtract both sides of equation by 2156.25, so we are going to have minus 2156.25. So on both sides, the minus will cancel. So the force at point A in x direction will be equal to 2156.25 divided by 1.25. So 2156.25 divided by 1.25 will be 1,725 pounds. So the force at point A in x direction, which is the same as at point C in x direction, is equal to 1,725 pounds. I need to get a new board. Now, the force, we found out that the force at point A in y direction is 4 times the force at point A in x direction. So the force at point A in y direction is equal to 4 times the force at point A in x direction. So it's equal to 4 times 1,725 pounds. So it's equal to 4 times is equal to 6,900 pounds. So this force at point A in y direction is equal to 6,900 pounds. Now, we know that force at point C in y direction is the same as force at point A in y direction. So this is also equal to 6,900 pounds. And force at point A in x direction is equal to 1,725 pounds. Now, in this picture, let's go ahead and take the summation of all the forces with respect to x should be equal to 0. Let's assume that this direction is the positive direction. So we have plus 125 pounds plus, this is positive, plus 1,725 pounds. This is the other side, minus force at point B in x direction is equal to 0. So the force at point B in x direction is equal to 1,725 plus 125, 1850 pounds. So at that point B, at the bottom of our pipe in x direction, we got this force is equal to 1850 pounds. Now, let's take the summation of the forces in y direction in the same picture equal to 0. Let's assume that the top position, the top part is positive. So we have this force going up, 6,900 pounds. This one going down, minus force at point B in y direction equal to 0. So the force at point B in y direction is also equal to 6,900 pounds. So this is also equal to 6,900 pounds. So that shows that in y direction, the force both on top of the pipe and on bottom of the pipe in y direction, they are equal, and both are equal to 6,900 pounds. So I believe if we found everything, this is all the forces that are acting on that pipe range. This is a bunch of force in a x direction. See, we got 1,725 pounds on the x direction. That means in this type of a range, you got to make sure that these teeth are grabbing your pipe good. Otherwise, with this amount of force in x direction, if it is not set right, if your wrench is not set right on your pipe, you are going to have a slipping problem. It's going to slip. So that is it. And I hope you liked it. I had one request. Someone, a plumbing contractor, he found my contact information from my website and wanted me to post a video on faucet nut wrench, which one of these things, I had a couple of them in my toolbox. And the reason he wanted me to post a video about this wrench to show the importance of this wrench. You know, this is the type of wrench that You don't use it that much, but everybody have a few of them. And the reason for that is since you don't take this tool serious, you don't put it in your toolbox when you go to a job site and you realize you need to have one of these tools. So instead of coming back to your warehouse and pick up your tool, you just go to a local hardware store and buy another one. And usually those nuts that hold the fixture on the sink, usually you can lose it by your hand, or with very small force you can lose it. But you know, you never know who has set that fixture on that sink. You know, a lot of do-it-yourself people that they want to do the job and they are not plumbers, when they see a knot, they just go at it and they tie it too much. And so it is very important to have one of these tools, you know, in your toolbox. So our next video will be about this tool. See you all later.